in lesson 4.5, we're going to apply the properties of an isosceles triangle. Now, listen, we're recording, so please stop talking. These properties might be in the forms of theorems and corollaries, and we'll explain what corollaries mean in just a moment. Okay? Okay, this page here has a lot of clutter on it, and I agree with that, and I apologize for that. This over here on the side,
Do we gotta write all this down?
this over on the side is just a different example I want you to see. Okay? This triangle ABC here is an isosceles triangle. Okay? It's an isosceles triangle. What makes it an isosceles triangle is these two sides are marked equal. And the definition of an isosceles triangle is at least two sides are equal. So that makes it an isosceles triangle. An isosceles triangle has a vertex angle that's the angle between the two congruent sides. Okay, and that's why over here I wrote between between the congruent sides. The legs are the congruent sides. And so the segment, or the side that's not a leg, is called the base. And then the angles at each end of the base are called the base angles. Okay? Pause, let you finish copying that down. We're recording again. Now this triangle off on the side, sometimes our triangles are not always sitting the way we expect to see them.
Yeah, but you still know that.
Okay? These two sides here are still equal. So where's my vertex? Let me label this. We'll go A, B, and C. Which one is my vertex angle?
C.
C is. C is the vertex angle because it's the angle connected to the two congruent sides. And so these are my base angles. Even though it's not sitting on its base, it's still the base, and these are still the base angle. Okay? Stop talking.
Sorry, I apologize.
So this triangle, even though it's not sitting upright like we would like to see an isosceles triangle, it still is an isosceles triangle. This is still the vertex angle. These are still the base angles. This is still the base right here. Okay? And these two equal sides are called the what? The legs. Okay? Good. Any questions on what's on this screen right here? That's just another example.
So the bottom would be the
The reason I drew this example is because the vertex angle is, what kind of an angle is that vertex angle? It's obtuse. So I want you to see that it's okay sometimes to even have an obtuse angle there. We still can have an isosceles triangle. These are the legs still, and this is the base. And these are the base angles right here. And this is still the vertex angle. Okay? Sorry, that's vertex. All right, so even if it's an obtuse triangle, we can still have an isosceles triangle with the base, the vertex angle, and the base angle. Okay? All right. Anybody not done with this page?
Nope.
Okay, isosceles triangle theorem. Let's copy this down. Here we go. Isosceles triangle theorem says that if two sides of a triangle are congruent, well, that's kind of the definition of isosceles, right? Two sides are congruent. Then the angles opposite them are going to be congruent. So that means this angle, which is opposite this side here, and this angle down here, which is opposite this side here, are going to be congruent. In some textbooks, they call this isosceles triangle base angles theorem. And it simply says the base angles of an isosceles triangle are congruent. In this book, they go a different route. They just call it isosceles triangle theorem. And this is not true in other polygons, but it's certainly true in all triangles. Whenever two sides are congruent, then always the angles opposite those sides will be congruent also. Okay? Always. Any questions or confusion on this? Okay. Now here's a question that I quite often put on the quiz, and everybody for some reason gets it wrong. Okay? Looks just like this. Different numbers, but looks just like it. What kind of triangle is this? Okay, why is it isosceles? How do we know that?
Two sides are equal.
Yeah, these two sides here are equal. They told me they were both 21. Now, they didn't tell me with these marks, but I don't need those marks if I know the lengths. Okay? So, if these sides are equal, then what do we know about these angles down here? They're equal. Do we know what they are yet?
No.
So what would we call them? X. That's right. I can put an X there. What do the three angles of a triangle always add up to?
180.
180. So I would say X plus 31 equals, can we make that 30?
Maybe.
Let's change that to 30. We could do 31, but we're just going to get a decimal that way. If I change it to 30, we'll have nice numbers. Okay? So now, this means how many x's do I have?
2.
So 2x plus 30 equals 180 minus the 30. Good. So 2x is equal to 150. Divide by 2. That's right, that's an x. So x equals 75 degrees. Okay?
So that's a 30, right?
That's a 30, yep.
Alright, it looks like 3D.
You look like 3D.
Okay. Okay, let's not go there. Just because things are funny doesn't mean we need to say them out loud. All right. Any questions on this screen? Okay. Yeah, you know what? You guys tell me that. Every time I point this question out, everybody says, oh, that's easy. And yet, every time I put this question on the quiz, half of you get it wrong.
I haven't seen this one.
Okay? No, because we're just learning it now. It'll be on the next quiz. Okay, here we go. The converse. The converse of the isosceles triangle theorem.
All of them.
Converse of the isosceles triangle theorem. Can you cover up the title so you can see the picture? It's just like the last one, except it has the word converse at the beginning. Here we go. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So this is the converse of the last one. The last one said if the two sides are congruent, then the angles opposite them were congruent. This is saying if these two angles are congruent, then the sides opposite these angles have to be congruent. Yeah. Yes, it just totally switches the two around. So what do we get out of the two of these? Is that if whenever two sides of a triangle are congruent, then the angles opposite them have to be congruent. Whenever two angles are congruent, then the sides opposite them have to be congruent. They always go hand in hand.
Wait, what?
You can't have a situation where you have two sides of a triangle equal and not have two angles equal. Okay? And you can't have a triangle where you have two angles equal and not have two sides. That's what this theorem is, these two theorems are telling us. Okay? They go together. Alright? Anybody not done with this one? Okay. The bisector of the vertex angle of an isosceles triangle, and you're right, my comma was misplaced, is also the perpendicular bisector of the base. Well, perpendicular means that this symbol here means perpendicular. It means that both of these angles are 90 degrees. Excuse me. Okay? So anytime you see a triangle and these marks are there, that means this is the angle bisector. That means these angles down here have to be 90 degrees. I should say, anytime you see an isosceles triangle that has the angle bisector. And it cuts this bottom side, the base, into two equal segments. So those two segments are equal. So if I know this one is 4, how long is this one? 4. That's right. And if I know this angle up here is 30, well, we'll just go 30, then what's this angle over here going to be? No? 60. 60 because 30, 60, and 90 add up to 180. Okay? Adds up to 180. All right. Corollaries. These are a little long-winded, so I'll give you time to...
Number 1.
Corollary is a new term for you. This is the first time you've ever seen it in this class. Corollary is a true statement that follows a theorem to give us more information. Remember, a theorem is statements that are proven to be true. Oh, goodness. Postulates, there we go. Couldn't get the word out. All I could think of is its other word, axiom. Postulates and axioms are those words mean that they're statements that we just accept to be true. And now we have another one, a corollary. And a corollary is simply a statement that follows a theorem. Okay? Sometimes they follow immediately, like these two do. Sometimes they follow later, like the next corollary you'll see will be in chapter 5 over something we do between now and then, and they're quite a ways apart. Okay? But the first corollary says, if a triangle is equilateral, then it is equiangular. So this first triangle here, all three sides are the same, so that makes it equilateral. This corollary says then that all the angles have to be equal then. This goes along with the theorem that said if two sides are equal, then the angles opposite them have to be equal. And so you notice these three angles are opposite these three sides. And so if the sides are equal, then the angles have to be equal. Okay? Then the second one is like the converse of it. It simply says if a triangle is equiangular, meaning all three angles are the same, then the sides opposite all of them would also have to be the same. So that means if it's equiangular, it has to be equilateral. Okay? There we go.
Is it done?